Today we are going to discuss on part 8.2 common runtime exceptions and checked exception rules. So first one is arithmetic exception. Int x is equal to 10 by 0. So integer division by 0 throws arithmetic exception. It's straightforward. But now look at this, double d is equal to 10.0 divided by 0. Here there is no exception. The result is infinity. This is how floating point arithmetic is defined. Dividing a double by 0 produces a special IEEE value called infinity, not a crash. Java only throws arithmetic exception for integer division by 0, never for floating point. This is a very important point we need to remember. This is one of the most reliable exam traps in this chapter. The moment you see division by 0, check whether the numerator is an int or a double before deciding what happens. Okay. And then we have null pointer exception. String s is equal to null and s dot length, right? S holds null. It points to nothing. When you try to call a method or nothing, the JVM has nowhere to go. Null pointer exception is thrown. The rule is very simple. Any attempt to use a null reference as if it were a real object, it will cause a null pointer exception. Then we have number format exception. Integer.parseInt, then within quotes ABC, and then integer.parseInt 10.5, right? So parseInt expects a string that represents a whole integer. ABC clearly is not a number, so it will lead to number format exception. But 10.5 also will fail, and this one surprises people, most people. It is a valid decimal number, but parseInt does not accept decimals. It wants digits only. So both throw number format exception. Remember that number format exception extends illegal argument exception. Okay, so it sits under runtime exception unchecked, no catch is required. And then we have ClassCastException, right? So animal A is equal to new dog and cat C and the cat A, right? So the actual object in memory is a dog. We are trying to cast it to cat. A dog is not a cat. They are completely unrelated types. The compiler actually allows this line because it cannot always prove at compile time what the actual object is. But at the runtime, the JVM checks, sees the mismatch and throws a ClassCastException. This is exactly why you should always use instance of before downcasting. Instance of lets you check safely instead of finding out the hard way at runtime. And then we have StackOverflowError, right? So void recurs. This method calls itself with no condition to ever stop. Each method call adds a new frame to the call stack. The stack keeps growing with no end in sight until it runs out of space entirely. At that point, the JVM throws StackOverflowError. Two important things to note here. First, it is an error, not an exception. It sits on the error branch of the hierarchy. And second, it is called StackOverflowError, not StackOverflowException. The exam expects you to know the exact name and exact branch. So checked exceptions throws keyword and caller obligation. Checked exceptions are enforced at compile time. They create a rule that the compiler makes sure you follow. If you call a method that declares a checked exception in its throws clause, you must handle it or declare it. You have two options: handle it with a try-catch block or pass it up adding a throws clause to your method. So if you do neither, the code will not compile. This is the key idea. Checked exceptions cannot be ignored like runtime exceptions. The throws clause is simply a declaration. It tells others this method might throw this exception, so you must handle it. Okay, so let's come to the code. So we have void read file string path throws IO exception and file reader fr is equal to new file reader path. File reader's constructor can throw IO exception. The file might not exist, the path might be wrong, the disk might be unreadable. These are external conditions outside your control. Because IO exception is a checked exception, the compiler requires read file method to acknowledge this. It does so with the throws keyword in the method signature. This is a declaration of intent, and read file method is saying I might throw an exception, IO exception, and whoever calls me needs to deal with it. Okay. So option 1 is catch it, and so void process try read file data and then catch IO exception E and system out the println file error e.get message. Okay, so here process method handles the IO exception locally. It wraps the call in a try catch and deals with the problem right there. The caller of the process has no idea any of this happened. Process takes full responsibility. Notice that process itself does not need a throws clause because it handles the exception internally. And then we have void process throws IOException read file data text, right? So method process decides it is not the right place to handle this. Maybe it does not have enough context to know what to do when the file is missing. So what it does is that it declares throws IOException in its own signature and passes the responsibility up to whoever calls process method, right? So the exception travels further up and up the call stack until something handles it. This is perfectly valid. You are not ignoring the exception. You are explicitly saying the caller must deal with it. Okay. And then we have void bad read file data.text. It will lead to compile time error. Method bad calls read file method but does neither. No try catch, no throws declaration. The compiler sees that read file can throw a checked exception, and that bad has made absolutely no provision for it. So this is a compile error. The compiler will not let you silently ignore a checked exception. The error message will say something like unhandled exception type IOException. Okay. Next is checked exception rules for method overriding. So the rules for checked exception in method overriding follows a very simple idea. The child method must not make things harder for the caller. This is based on polymorphism. When code calls a method through parent reference, it only knows about the exceptions declared in the parent. So the child method can throw the same checked exception, throw a more specific subtype, or throw nothing at all. All of these are safe because the caller is already prepared. However, the child method cannot throw a broader exception or throw a new unrelated checked exception that would break the caller's expectations and cause problem. Okay. One important exception to this rule is that unchecked exceptions are not restricted. You can freely add, remove, or change unchecked exceptions in an overriding method because Java does not force callers to handle them. Okay. So let's come to the code then. Okay, so void method throws IOException. The child declares exactly what the parents declared. No surprise for any caller, so it's fine. And then we have void method throws file not find exception. File not find exception is a subtype of IOException. The caller prepared to catch IOException, and since file not found exception is an IOException, the caller's catch block will handle it just fine. The child is actually being more specific and more helpful, so this is allowed. Okay. Then we have void method, and the child simply does not throw anything. Okay, the caller prepared for IOException and nothing happened, no problem at all. The override is making things very easier and not harder. Okay. Then we have broader exception, that is compiler error. So we have void method throws exception. So exception is the parent of IOException. The caller only prepared to handle IOException. Now the child is saying it might throw any exception at all, right? SQL exception, interpreted exception, anything. The caller is not prepared for those. This breaks the contract, so the compiler rejects it. Okay. So next we have unrelated checked exception, compile time error. So void method throws SQL exception. SQL exception has nothing to do with IOException. The caller never prepared for it. Same problem as ever. The child is introducing a surprise the caller cannot handle. So it will lead to compile time error. And then we have void method throws runtime exception, and it is unchecked exception. So unchecked exceptions are exempt from this rule entirely. The compiler never forces callers to handle unchecked exceptions in the first place. So adding one in the override cannot break anything. So you can throw any unchecked exceptions in any override regardless of what the parent declared. Okay. So pattern is very simple. Once you see it, same, narrower, or nothing. These are all valid. Caller is not surprised, and broader or new checked exception, it will lead to compile time error. So now we come to our practice question. So practice question answer is actually B, line B and line C. So this question actually tests exception rules in the method overriding. Okay, start with parent class base. So it method declares throws IOException. In class sub void action throws exception. So exception is broader than IOException. That means the child method is trying to throw more general exceptions than parent promised. Any code calling base.action is also prepared for IOException, not all exception. So it will lead to compile time error. In class sub2 method is void action throws file not found exception. File not found exception is a subtype of IOException. This is more specific, not broader. any caller that handles IO exception will also handle this. So this is valid. It will compile fine. In class sub 3, however, the method is void action throws runtime exception. Runtime exception is unchecked. So Java does not force callers to handle unchecked exceptions. So this does not break anything, and unchecked exceptions are always allowed in overrides. So this is valid. It will compile fine. Okay. So if you want to practice such questions, we have 1624 questions in javalearn.clustermicro.com, and they have very detailed explanations, and we have 29 full-length practice tests with timed exams, so you can practice and get more knowledge there. And so thanks for your time.